Now, wiring limitations. You've probably heard this number, 1900 meters. And that is the maximum total length of a segment. And that total length is the combination of spurs and trunk. Everything added up, okay? And that 1900 applies to a non-intrinsically safe segment. Intrinsically safe segments limit it pretty drastically. Well, I will show a little bit about that later on. The number of, or the spur length depends on the number of devices on that segment. If you stick within the 1 to 12 devices per segment, which is the recommendation from the AG 181 from the users, all right, then the maximum spur length is 120 meters. Will 121 meters not work? Nope, that doesn't mean that, right? This is what was tested, so they know that's going to work, right? So you're not, the world doesn't fall off the edge, you know, at the edge here if you go 121 meters or 100, even 130. Depends on lots of things. So it's a real guideline, but it's something you want to try to stay within. All right?
Has to do with attenuation.
Yeah, but again, with today's wire, it's not so much of a problem, and you know, they tested this. This is what they came up with as a working max. Okay. Now, in the old days, there was type A, B, and C wire. This statement here says no longer relevant. That should read not as relevant. All right. Most of us in the process industries that are around here use the equivalent of a type A, twisted shielded pair. Yeah. That's what a registered field bus cable is. So if you stick with the registered cable, that's what you're going to get. So don't worry about the other stuff. Unless you're in a situation where you have to use existing wire, then you need to look at it. All right? Good engineering practice. All right. So, what was the first thing? Area classification. There's lots of ways to mitigate it. And here's some ways. This Fisco and Finico are applied to field bus. If you take like the Finico Fisco, the field bus intrinsically safe concept, there are limitations on wire length and wire itself and devices and yada, this and that and the other. They've made some calculations and said, all right, if you stay within these boundaries, then you don't need to do the calculation. You can also increase the number of devices, so forth and so forth. All right. Finico is a similar thing for non-incentive. However, that's kind of going away in today's world, and it's being replaced by IEC EX. So don't worry too much about it. I think most things in North America are non-incentive, right? And we have the hybrid, the non-incentive trunk and the intrinsically safe spurs. Lots of ways now. The limitations, like I said, you can have limitations in, for instance, in intrinsically safe, and by going with a Fisco, you can increase that. Normally, it was like 4 to 6 devices for intrinsically safe. You can get up to 8 to 12, really with no big problem. This hybrid, we talked about that one earlier, where you can extend things by having a non-incentive trunk, optically isolated, and intrinsically safe spurs. So in theory, you can have 2 sets of 1900, you know, one for the trunk and, well, not 1900, 1000, I guess, on the intrinsically safe spur. All right, so you can really get some huge lengths out there if you need to.
Is that study on the disk
The Furios? It's not on the disc, but I believe you can go to the website and technical references, and you can get to it. Okay, so voltage drop is another scenario you need to think about. And again, it depends on what was the first thing? Area classification. If you're non-incentive, 30 volts is the max. If you're intrinsically safe, 17.5. So you need to buy your field bus power supply accordingly. All right, so that's what you start with. And there are several different variations within that suppliers have put out. So figure out what you need, figure out what you've actually bought, and go from there. That's where the segment length then comes in, and you figure out what the voltage can be and what your maximum quantity of devices can be. And that kind of varies with device types, because some draw more power than others, and this and that and the other thing. But the idea is that if you stick within the guidelines that are within AG 181, which is basically limiting to 12 devices, that accounts for a lot of safety factor, okay? Then you're okay, and you don't need to do the calculations. Okay? The minimum voltage in this is 9 volts. It's 9 to 32, right? You do not want to design a system that is at 9 volts. You want to give yourself some oops factor, right? So some devices actually turn on around 10 volts, 11 sometimes, all right? So the recommended practice would be to make sure that you have at least 13 on all your devices, and then you're home free, aren't you? Okay? Good common sense. Don't design to the ragged edge. There's a couple of devices out there like radar level that actually require more voltage than you would think. It's like 16 volts, so if you've got that, work that into your design. Current, again, the more devices, more current you're going to draw. Different devices draw different currents. So you want to look at the quiescent current for each device that you've got. Steady state. You want to allow for some inrush. If you have them, everything's hooked up and you turn it on one time, you're going to get a little inrush, all right? So normally we use like 25% factor on top of everything else. You want to allow for one short circuit to happen at any given time. And usually that, depending on the type of short circuit application you buy with the device couplers, it's in the 50 milliamp range, all right? Plus or minus. Figured out who you actually bought and what your real number is, but it's around 50 milliamps. Diagnostic tools, you want to hang something on there every once in a while and look at a segment, and that's usually in the 10, 11 milliamp range, but it could be as high as 30-ish, right? Figure out what you're going to use, what's your worst case, design for that. You want to leave some spare allowance. All right. We said 12 devices is the recommended max to make sure everything works fine. Don't start a project with 12 devices on the segment. Leave some room, all right? Leave at least 2 spares. And you'll find that when you look at the other scenarios, you'll probably get down into the 8 or 10 device range anyway, okay? Somewhere along there.